Hi, my name is Forrest Schuster, and I'm the lead engineer on the Get a Grip Enterprises Multidisciplinary Senior Design Group. We are working on a project called GRIP, or Gamified Rehabilitation for Independent Practice. We chose to create the device in such a way as to measure the same angles produced in the prosthetic on a healthy human hand. This device sends a packet representing the movement of the degrees of freedom of the prosthesis. This packet is then interpreted by the serial interface in the game engine, which uses pre-built calibration profiles for each user and device to account for variability in hand positions, hand shape, and parts. We chose to use a teensy 3.2 microcontroller due to its large number of analog inputs, its small size and weight, and its low latency for communication with our game. This selection screen allows the user to select from 6 movements, and the more degrees of freedom chosen, the higher the difficulty of the gameplay. Once the desired degrees of freedom are chosen, the gameplay begins. The training game we've created takes on the format of a standard rhythm game, with each of the notes of the game being designated to a specific movement position of the hand. As you can see here, the movement of this bar correlates with the movement of the degree of freedom we chose. The player can control the motion of this cursor and hit each note by extending and flexing their finger. And now, with completion of the song, we can see how well the player did via exported performance metrics that can then be used to perform step response characterization of the amputee's performance during gameplay. We are collaborating with a group in Cleveland, Ohio called the Functional Electrical Stimulation Lab, the Defense Advanced Research Projects Agency, and the Case Western Reserve University to design a portable training game for users of myoelectric implanted transradial prosthetic limbs. Our project allows us to improve amputee patient outcomes through improved continuum of care by creating an engaging at-home training experience, and we hope that one day all of these such patients find their new lives with prosthetics a bit easier when using GRIP.